Assalamu alaikum. Today we are going to discuss the topic hexadecimal number system. The code that we have for the computer science, which is IGCSE, it's 0478. For O levels, it's 2210. Chapter number is chapter 1, data representation. In the previous slide, in the previous video actually, you studied about the binary number system. If you want to go back to that, you can go and refer to that. We in this slide, in this actually presentation, are going to discuss what actually hexadecimal number system is. We in O levels we study three number systems, which is binary, which is ternary, and which is hexadecimal number system. Before we begin, let's just introduce myself. I am Shaila Naeem. Let's just move on to the next slide. What actually is a hexadecimal number system? It is actually base 16 number system, and it is used to represent large binary numbers. Actually, binary numbers, they go very long when it comes to the space and storage. So in order to just avoid that, we use hexadecimal number system. It is common in computer systems and actually, when we talk about the digits, or we call the values, there are total 16. This is why we call it a base number 16. It starts from 0 and it ends at 15, but there's a little different in terms of the representation. And what's that? Let's just quickly go through that. It uses 16 symbols, in which 0 to 9 are the values, which means they are used as proper numbers or the digits. But when it comes to 10, 10 becomes A, or A becomes 10, however you call it. The last number that is used in this case is the 15, but 15 is represented at F. Wherever you are using the number 15 and it is representing hexadecimal, that needs to be converted into F. In simple, you just have to write 15 equals to F, or F equals to 15. For B equals to 11, E is 14, C is 12, and D is 30. Now, why hexadecimal is used? This is something that you need to know, because binary is something that is used inside the system, because the system only understands binary number system. Why hexadecimal numbers used? Because binary numbers, they are really very long, and in order to have the shortened form of the binary, we uses hexadecimal number system. Easy conversion with binary, that's one of the main thing. The color codes are represented, the error codes are represented, the memory addresses are represented using the hexadecimal number system. Now let's just talk about the place values. When it comes to the place values, these are the powers of 16, and we start giving the power from the right side, just like we do in an Urdu. Just like we write the Urdu numbers, या उर्दू की जो गिनती होती है वो हम लिखते हैं. Instead of writing it from the left in a normal scenario, we write it from the we give the values from the right side, which is 1, and the next value becomes 16, and then 256, 4096, and so on. Now, when we have to convert binary to hexadecimal, just to have a quick recap, binary is only the combination of zeros and ones. There's no third number that is used. There can be multiple combinations of zeros and ones. So actually what happens is, when we have to convert binary to hexadecimal, if these are 16 bits, so what we do is we make groups of 4, or 4 bits, and then we have to convert each group into hexadecimal. That becomes 1248. We again start giving or grouping from the right side. That remains 1248, the next group 1248, the next group 1248, and so on. In this slide, we are going to look at the example that will become easy to understand what I just said previously. For example, if we have binary number system, which is 11010110, if we have to change it to hexadecimal, we are going to make two pairs, two groups, not pairs. We are going to make two groups, which means starting from the right side, we are going to take 0110, that's one group, and then we have 1011, that's another group. So 0 has the value 1, then it's 2, and then it's 4, and then it's 8, and so on. Just like you can see now, there's a little space between these two groups. And now what happens is, how we have got this number: 0 has the value 1, 1 has the value 2, the next one has the value 4, and the next one has the value 6. But what happens is, all the values that are written with zeros, they are going to cancel out. We are just going to add the values that are only written on ones. That's how it is converted and changed into these number systems. And if you just see the next group, which is after the 6, that has the value 13. So 13 has been changed to D. So how are we going to write it? We are going to write it as 6. Now hexadecimal to binary number system, it replaces each hexadecimal digit with 4-bit binary. Let's just quickly look at the example. In the previous slides, we studied or we learned about how to change binary to hexadecimal. Now we are going to change how to convert hexadecimal to binary number system. In the hexadecimal number system, if you have gotten the value A3, which means it's 10 3, so we are going to deal with this separately. How? 10 and 3 are going to be simplified, and they are going to be changed by using the value 2, because we are changing it to binary number system. We are going to write them together, starting from the left side or starting from the right side, whatever you understand it. Ideally starting from the right side. So if there are 7 bits, we add an additional 0 to the left side, because if you are going to add an additional 0 to the right side, that entirely changes the value. So we divide it by 16, we write the remainder. The remainder is actually the answer. Use A till F for 10 till 15 and read bottom to top. This is the rule for dividing to hexadecimal. Now, if you want to look at the example, this is 47 divided by 16 equals to 2. Like 16 times 2 is 32. So if you are going to minus 47 from 32, that is remainder 15. So this is how we are going to write it. And again, 16 and 2, 0 is the answer. The remainder becomes 2. So hexadecimal value is either you call it 0 to 15 or 0 to like 215 and then change it to 2 and F. That's how we write the number when we are converting it from denary to hexadecimal. Now the other thing is hexadecimal to denary, multiply digits by place values and add the results. The example, if you just see 3 and A were there, so we are going to multiply 3 with 16 and A will be changed to 10, and then this will be multiplied with 1. So because since we start giving the values from the right side, so 10 will be multiplied with 1 and 3 will be multiplied by 16. और अगर उससे भी आगे आगे कोई numbers होते तो वो उनके accordingly उनको हम convert करते रहते. Now we are going to multiply them. 3 times 6 is 18. 3 times 1 is 3 and plus 4. That's 48 and 10. So that becomes 58. Ideally, when we talk about the exam tips, you have to show the working, you have to learn the hexadecimal values, and you will learn them through practice. You have to group the binary correctly. Correctly means you start from the right side, you make the groups of 4, and this is how you can make groups. You can change them, you can convert them, and then you can write them together. So this is how we actually